Hello everyone. On behalf of Unacademy, myself Prasad, I welcome all of you for this amazing session on hybrid electric vehicle. In today's session, we are going to understand hybrid electric vehicle powertrain sizing. Till now, we have understood that what are various basic parts of hybrid and electric vehicles. Just quickly, we'll have review or recap of whatever we have discussed till now. So we have understood that the internal combustion engine based vehicle, maybe it is a petrol based vehicle or a diesel based vehicle, has various parts such as engine, fuel tank, alternator, carburetor, exhaust system. Along with that, it is having engine management system, that is EMS. Also, we have learned that in case of electric vehicle, we are having various important parts such as battery, which acts as a heart of electric vehicle, which acts as a energy storage, and along with that, for propulsion, we are using motor. So the energy which is stored in the battery in form of electricity is provided to the motor, so that motor works and it activates or it acts as a propulsion system, and you can move from one point to the other. Along with this, you need a controller. Like for our body, our mind is a controller. Okay, so via nervous system, we can control all our organs. In same way, in case of electric vehicle, you have to have a controller which controls the flow of signals to various components. So it is having controller. Along with that, it is having some DC to DC converters, because there are two or more voltage levels on which the electric vehicles operate. Okay, also there is a battery management system which takes care of voltage, current and state of health of the battery, and also there is a vehicle control unit. When the conventional electric vehicle and the IC engine based vehicle, okay, these two come together, it forms a hybrid electric vehicle. And we have learned many things till now about hybrid electric vehicles. We have understood hybrid electric vehicle is the any vehicle which is having two or more sources for propulsion, but at least one of them should be electrical motor. Okay, so we have understood that hybrid electric vehicle can be a vehicle which is having the IC engine and a motor connected in series or parallel. We have learned various configurations also. But the every hybrid electric vehicle is having electrical motor, and along with that there is a battery energy storage, there are DC to DC converters, there is onboard charger. So what are components are there in case of electric vehicle? Some of those components are as it is placed in the hybrid electric vehicle, but along with that there is a IC engine, there is a fuel tank, there is an alternator, carburetor and exhaust system present. So this is what we have understood till now about the hybrid electric vehicles. Then we have understood what are different schematics of hybrid and electric vehicle powertrain. We have understood that in case of conventional IC engine based vehicle, we are having IC engine, okay, which is converting the thermal energy into mechanical energy, and this thermal energy is produced by the chemical energy which is present inside the fuel. So it can be a gasoline engine or a diesel engine from which we get the mechanical energy. This mechanical energy is provided to final drive, but before that you are having a clutch and a gearbox. So we have understood the importance of every component, like what is importance of clutch, what is importance of gearbox, and we have also understood same in case of electrical vehicle, that electric vehicle has various components including battery, how battery is connected to electrical motor. Then in case of electric vehicle you are having a single, what you can say, gear, because electrical motor is capable of operating at various torques and speed. That is not the case with the conventional vehicle. And when you combine both the electric vehicle and the conventional vehicle, it forms a hybrid electric vehicle. So we have understood the schematics, we have understood what are various components based on the powertrain inside electric vehicle, and we have also understood that how these powertrains are connected. And under this, we have understood various types of electric vehicles such as series hybrid electric vehicle, parallel hybrid electric vehicle, and we have understood that series hybrid electric vehicle configuration is mostly used in heavy buses, trucks, because in case of these vehicles, you are having a huge area and weight of powertrain. So I gave you example of Tata Starbus, which uses series hybrid electric vehicle configuration. Also, we have learned parallel hybrid electric vehicle, and in case of parallel hybrid electric vehicle, like here we have shown, the IC engine, clutch, gearbox are connected in parallel with the electric powertrain, that is battery, motor, and further it is connected to final drive. So parallel hybrid electric vehicle configuration is very much comfortable in case of four-wheelers. So Toyota Prius is one of its example, and many hybrid electric vehicle which are parallel are coming into existence. So here you will find IC engine independently can provide the power to the final drive, or the battery along with motor can provide the independent power to the final drive, or both of these can come together. Okay, so parallel hybrid electric vehicle configuration helps us to gain more flexibility, and hence in most of the four-wheelers those are hybrid. Parallel hybrid electric vehicle configuration is being used. So it is combination of conventional IC powertrain and the electric powertrain. Then we have understood what are different components in case of electric vehicle powertrain. We have understood importance of battery. We have understood importance of motor. We have also understood here that what are the various electronic converters are used, like inverter, which converts AC into DC, and also DC into AC whenever we want to have regenerative braking. So if I want to show you the complete schematic, it is how it looks. Okay, so we are having a charger which is an external, you can connect it to vehicle, and the onboard charger, OBC is what? Onboard charger. It takes care that you are converting whatever AC power is available as an input, it gets converted into DC, it is getting provided to the battery, and then from the battery, as motor can be a DC motor or a AC motor. Further we are going to understand detail what are different types of motor that are being used in electric vehicle. But if this is an AC motor, then this battery is storing energy in DC, so this DC has to get converted into AC. For that this inverter is required. Also, if there is regenerative braking, whenever braking is there or slope is there, the electrical motor is going to act as a generator, so the energy will flow in the reverse fashion. So this inverter should be able to convert AC into DC also in that case, and conventionally it should convert DC into AC. So it is a bidirectional converter. So in some of the reference textbooks you will find it is not called as an inverter, it is called as a converter. Okay, so we have understood important components in case of electric vehicle powertrain. We have understood there is an electrical motor, inverter, battery, onboard charger, various types of enablers are there, battery management system is there. The recap is very much important because you have to get connected. Whatever you have discussed, we have understood in previous session. That's why understanding the recap, quickly revising the concepts is very important. So we also understood how electrical energy power flow takes place in electric vehicle. We understood that there are different voltage levels under which the electric vehicle operates. Mostly for the battery, which is a high voltage battery, and the motor, which is a traction motor, which actually leads to movement of the vehicle. These are operating at higher voltages. Whereas there are few auxiliaries like heating, ventilation, and air conditioning. Okay, then there is brake volume pump. Then there is a music system, head or tail lamps, indicators, and also the steering, electrical steering system. These are operating at lower voltages as compared to the voltage at which the motor operates. So here there are two different voltage levels. So different power electronic converters are involved, and different kinds of operations are taking place at different voltage levels. We have already covered this. Also, we came to know how exactly electric vehicle dynamics is done, and vehicle dynamics is one of the important parts when you are designing any kind of vehicle, whether it is IC engine based vehicle or electric vehicle or hybrid electric vehicle. So here we have understood that there are three main forces that we have to take into consideration. Force number one is a rolling resistance force. Here we have denoted it by FR, and I hope all of you remember the equation. Can you quickly recollect? Can you please quickly recollect FR equation? Rolling resistance force, FR is CR mg cos alpha, where alpha is angle made by the vehicle with the reference horizon, or sometimes it happens that you are moving through ghats, you are having some elevations, you are having bridges and flyovers. So your vehicle has to climb that, and for that you have to take into consideration the angle that road is making with the horizontal. So that is nothing but alpha. So rolling resistance force acts on the wheels, and as wheels move forward along the road, they are going to they have to overcome some force that is called as rolling resistance force. Second is drag force, which is nothing but the force which acts on the front side of the vehicle. When you are moving the vehicle on the road, of course there is going to be some force that is going to oppose, that is called as aerodynamic drag force. And we have understood that aerodynamic drag force is 1/2 CD rho A into V square. Okay, so it is proportional to square of the velocity. And the third force is a gradient force, which is mg sine theta. And we have understood that gradient force is very much important considering the movement of vehicle along the elevation or the slope. So total power or the tractive force required is nothing but, if you remember these equations, we have understood that tractive effort is equal to m dv by dt. It is nothing but mass into acceleration. It is the force that is required, plus cr mg cos alpha. This is nothing but what? Fr. It is rolling resistance force, plus 1 by 2 cd rho a into v square. In some of the reference or textbooks, you will find v plus vw square, considering the speed more than 90 kmph. But generalized equation is 1 by 2 cd rho a into v square only. So this is a nothing but what I can say, aerodynamic drag force, and the last is mg sine alpha, which is nothing but gradient force. So till now we have understood this much. Now it's our time to go ahead and design the powertrain that will help us to move the vehicle from one point to the other. So while designing the powertrain, we have to take into consideration all these factors which we have discussed in previous lectures. So it was very important for me to give you quick recap and quick what you can say summary of what we have discussed till now. So let's move ahead and understand the powertrain sizing. Now powertrain sizing here is a part which can be divided into two sections. Like we are having hybrid electric vehicle, so the two sources are available. One is the conventional IC engine. Okay, conventional IC engine powertrain consists of the IC engine. Along with that, there is a clutch and a gearbox. And also we have to take into consideration the designing of electric powertrain, which is nothing but a battery and electrical motor. So ultimately we have to design these 3-4 components depending on how much amount of torque and speed is required by the vehicle. So we'll be diving deep into all the aspects of powertrain sizing. At the end of this powertrain sizing, we'll be able to understand how the gearbox ratio is prepared, how the motor selection is done, the battery selection is done, how we can understand the motor battery capacity and also the engine capacity. So let's move ahead and quickly understand with an example. For example, we are having a simple data in front of us. Like we are having a table wherein we have been provided with the vehicle which is running on the gasoline and whose gross vehicle weight is 1381 kilograms. Maximum speed that it can attain is 160 kmph, and also maximum width in case of millimeter, it is around 1760. Also overall height is given, it is 1510 mm. Ground clearance is given 165 mm, and tire width is given 195 mm. So here the task is considering this table of four-wheeler specification. It is designed with such performance that vehicle pickup is like to achieve 0 to 60 kmph in 6.4 seconds. 0 to 60 kmph in 6.4 seconds, and it can easily ride at 27% gradient slope. This is very much important because whatever vehicle powertrain we are designing, we have to take into consideration the movement of the vehicle on all types of terrains. So here we have to take into consideration the vehicle which can move easily along 27% gradient slope. Okay, so whatever data is given to us, this 27% gradient slope has to be converted into the angle in terms of radian or degree. So we have to find out the initial tractive effort required considering the specification and performance requirement. And here the air density is also given 1.17 kg per meter cube. Rolling resistance coefficient, that is CR, it is given, it is 0.01, and CD is also given, it is 0.342. So this is actually exercise. So I request you to please think over this. Of course, we are going to solve this in this lecture immediately. But whatever we have discussed till now, that is rolling resistance force, the gradient force, the aerodynamic drag force, here in this exercise, we are going to do calculations of all these forces. So let's quickly start, and first of all, understand that first and most important hint is whatever gradability is given here in terms of percentage, that is 27%, has to be converted in terms of radian. Okay, or if you wish, you can convert it in terms of theta. Once you get in radian, you can easily convert into theta. Okay, so gradability in terms of radian can be obtained as tan inverse of x divided by 100. That is nothing but tan inverse of 27. Here it is given 27. So tan inverse of 27 by 100. If you immediately do this on calculator, you will get the gradient slope angle alpha in form of radian. I request you to please have calculators so that you can do this calculation with me, and it will be very easy for you to understand how exactly to design powertrain. So I highly recommend that all of you are having calculator with you so that you can do calculations quickly and understand the concept in detail. So first of all, we have to make sure that we convert whatever percentage gradient is given into the angle that is in form of radian. Okay, second and most important thing that we have to understand is many people make misconception that whatever front area is given directly, people what they do is multiply the overall width, that is maximum width, here it is given 1760, by the overall height. But it is not the case. When you are considering a four-wheeler, if I try to draw over here, if you are considering the four-wheeler, then this is the frontal area, but of course here we are having wheels. So there is some gap between the road and the frontal area. So we cannot directly consider the total height into total width for doing calculation. We have to subtract this area, which is nothing but ground clearance. Okay, so here you have to take into consideration the effective frontal area, that is equal to overall height. Okay, whatever overall height is given, here it is mentioned 1510 this, okay, minus ground clearance. Ground clearance is given 165, so that is nothing but this, the distance between the road or the surface and the bottommost part of your vehicle. Okay, so you have to subtract the ground clearance from the overall height. You have to multiply it by maximum width, okay, into 0.95 plus GC is again ground clearance into tire width, because these tires are somehow going to get also affected by the air that is blowing. So always make sure that you don't create misconception by directly multiplying the overall height of the vehicle with the overall maximum width to calculate the effective frontal area. To calculate the effective frontal area, again I am repeating, you have to write overall height. Here it is 1.51 meter. I am also having calculator. I will do calculation for you. Overall height is as you can see, overall height, okay, it is 1510 millimeter minus ground clearance. Ground clearance is about 165. So 1510 minus 165 into maximum width. Now maximum width is 1760, okay, into 0.95, okay, plus it is given GC, that is again ground clearance, so it is 165 into tire width. Tire width is how much? Tire width in mm is 195. Okay, so it turns out to be around 2281. It turns out to be around 2281 in terms of what you can say the parameters. And I request all of you to do this calculation. If you do in terms of considering the similar digits, you will get the answer 2281 015. Okay, we are going to this calculation further. Just I want to make sure that you have understood the concept of calculation of effective frontal area. Now let's go ahead. Here we are having two challenges. As I told you, first of all, we have to calculate the alpha. And I told you that calculation of alpha is nothing but tan inverse of x by 100. For us, x given, x is 27%. So if you do tan inverse of, quickly, if you do tan inverse of 27 by 100, in terms of radian, you will get 0.2637 radian. Already I have mentioned the answer over here, but I request you to solve this on the calculator so that you will understand the better way. Next, rolling resistance force is CR mg cos alpha. So the gross vehicle weight is given. I'll quickly take you on the previous slide so that we'll understand the gross vehicle weight. It is 1381. It is 1381. So gross vehicle weight is 1381. So mass is given 1381. CR value is already given. So whatever values are given on previous slide, I request you to note down these values. I'll again give you some time. Okay, we are going on previous slide. So value of CR is given 0.01. Value of CD is given 0.342. Gross vehicle weight is given. I request you to note down all these values so that immediately we will solve.